Beneath busy cities, a massive machine can excavate soil and rock without stopping life above. This is a tunnel boring machine, or TBM, but it is far more than a giant drill. As it advances, it excavates the ground, removes the spoil, and creates a permanent tunnel lining behind it. So how does this incredible underground system actually work? At the front of the TBM is its most important component, the cutterhead. As this enormous wheel rotates, powerful disc cutters press against the ground and break soil and rock into smaller pieces. The broken material then passes through openings in the cutterhead and enters the machine where it can be transported away. The cutterhead is carefully designed according to the type of ground being excavated, whether it is soft soil, hard rock, or a mixture of both. Once the cutterhead breaks the ground, the excavated soil and rock must be removed continuously. The material falls through openings in the cutterhead and is collected inside the TBM. From there, a powerful conveyor system carries the excavated material toward the rear of the machine, where it is transferred out of the tunnel for disposal or further processing. This continuous removal system is essential because the TBM must keep moving forward without interruption. But how does this enormous machine actually move forward underground? The answer is hydraulic thrust. Powerful hydraulic cylinders inside the TBM extend and push against the concrete tunnel lining that has already been installed behind the machine. This reaction force pushes the entire TBM forward toward the excavation face. As the machine advances, a new section of tunnel space is created in front of it, ready for the next lining segments to be installed. As the TBM advances, it doesn't leave the excavated tunnel unsupported. Instead, specially manufactured precast concrete segments are brought into the machine. Each segment is curved and precisely engineered to form part of a circular tunnel ring. The segments are transported into position and prepared for installation behind the cutterhead. Once assembled, these concrete rings become the permanent structural lining of the tunnel. Now comes one of the most impressive parts of the process. A powerful hydraulic segment erector picks up each precast concrete segment and carefully moves it into position. The segment is rotated and aligned with the previously installed pieces, creating a precise circular ring. One by one, the segments are placed until the complete tunnel lining is formed. Behind the TBM, these rings continue to build a strong and permanent tunnel structure. Once the concrete segments are positioned, they must be securely connected to create a continuous tunnel lining. The segments are bolted together at their joints, while specially designed sealing gaskets between the segments help prevent water from entering the tunnel. Precise alignment is critical because every ring must fit tightly with the next. When thousands of these segments are assembled, they create a strong, durable, and watertight tunnel lining extending for kilometers underground. And this is where everything comes together. The TBM continuously cuts the ground, collects and removes the excavated material, uses hydraulic thrust to move forward, and then installs a new concrete lining ring behind it. Once the ring is secured, the machine advances again, and the entire process repeats. Cut, remove, push, install and seal, again and again. This continuous cycle allows modern TBMs to construct tunnels that can extend for kilometers beneath cities, roads, and even waterways. Now the entire process works as one continuous cycle. Cut the ground, remove the spoil, push the TBM forward, install the concrete lining, and seal the joints. Then the cycle starts again. This precise sequence allows TBMs to construct tunnels for kilometers beneath cities, roads, and waterways. If you enjoyed this engineering journey, like, share, comment, and subscribe for more civil engineering videos.